All right, I'm going to try and get these done as quickly as possible. You have two weightlifters, one 1.5 meters tall, one 2 meters tall. They raise identical masses above their heads. Compared to the work done by the weightlifter who's that tall, the work done by the taller weightlifter is work is force times distance. The force that they're applying is the weight of the mass, and they're identical masses, so 50 times 9.8 is the same for both of them. So it's just a question of who lifts it higher. The guy that is 2 meters tall is going to do a greater amount of work then, because their D is greater than the 1.5 meter tall weightlifter. Next question, if the time required for a student to swim 500 meters is doubled, the power developed by the student will be. So power is work over time. So power is proportional to 1 over time. It's an inverse relationship. So if you double the time, all right, you're doubling the number in the denominator, that means your power is going to be 1/2 as much. So it's going to be halved. If you want to test this with numbers, you can obviously do that. It just might take you a little more time. Which graph best represents relationship, and we're going to do this quite often, relationship between gravitational potential energy and height. So when it's graphed, the relationship means the equation. So the equation for PEG is equal to mgh. Again, if you compare the energy to the height, it's a linear relationship. So this is your best answer. This is an inverse relationship. This is a square relationship, and this is constant. There is no relationship. As H changes, PE doesn't change at all. So neither of those are the correct answers. Next question. The work done in moving a block across a rough surface and the heat energy gained by the block can both be measured in. So work and energy, what unit are they? The unit is joules. A joule is a Newton times a meter. Next question. Which graph best represents the relationship between kinetic energy and velocity? Again, we write out the relationship, which is just the equation, and you see that kinetic energy and velocity is a square relationship. I usually write it like this. Ke is proportional to V squared. So as V goes up, Ke goes up a lot, which is your exponential relationship. That's your answer. Next question. Zach does 300 joules of work pushing a cart 3 meters due east, then does 400 joules of work pushing the cart 4 meters due north. The total amount of work done by Zach is, this is a trick question. They're giving you the east and the north to make you think about vectors. Energy and work are scalar quantities. So you don't have to do vector addition. You don't have to do a squared, b squared equals c squared. You just add them. So 300 joules plus 400 joules, 700 joules. The direction is irrelevant because it's a scalar quantity. Next question. 45-kilogram boy is riding a 15-kilogram bicycle. So the total mass is 60 kilograms. With a speed of 8 meters per second, what's the combined kinetic energy of the boy and the bicycle? Kinetic energy is 1/2 mv squared. So it's 1/2 of 60 kilograms times 8 meters per second squared. This is 30. This is 64. I think that's 1920 if you do the math. A 1,000 Newton force causes a spring to stretch 0.2 meters. So this is your force on the spring. This is your stretch of the spring. What is the spring constant K? Our relationship is F equals Kx. 1,000 newtons equals K times 0.2 meters. K is equal to 5,000. And you got to be careful here. This is where units come in and are important. It's newtons per meter, so that is not the right answer. It is this one. Take your time. Last question on this page. A 40-kilogram student, that's the mass, runs up a staircase to a floor that's 5 meters higher. That's the height, or D. Then her starting point in 7 seconds. The student's power output, we did this lab. Power is work over time. which is force times distance over time. The force that you apply going up the stairs is just equal to the weight. So it's mg times d over t. So it's 40 kilograms times 9.8 meters per second squared times, I think, 5 meters, if I see that correctly, divided by 7 seconds, which ends up being somewhere around 280 watts.